All righty, thanks the few who decided to check out some Android today. So today I'm going to talk to you about developing for foldables and large screens with Android. So as Anki mentioned, I'm a Google developer expert. So that means I go around and do lots of these sorts of talks. So before we start, it's always a good idea to know how many people have worked in Android before. Put up your hand if you've done some Android development. Couple in the room, that's all right. Some people lying at the back there. So it's good to know there's a few people here. I'm not going to go into too deep in the code. I have a little bit in here, but mainly what I'm going to talk today about is the things you might think about if you're starting to develop an app for a larger screen or for a foldable device. So even if you haven't got started with development, you can still start using these ideas and think about it if you're going to start your development journey. So why might we think about foldables? You know, it's such a hot topic at the moment. There's lots of new devices. When we're comparing a foldable to a phone, we have increased screen space when the device is unfolded. So when it's closed, we have a smaller amount. When it's open, we have more space that we can use. We've got improved multitasking. With the newer updates of Android, you can run apps side by side. This gives us some new possibilities for things like gaming. So could you display different content on one screen versus another screen? And there's enhanced media consumption. Having more screen space means we can see our video or our movie much larger, but also we might be able to interact with the comments while the videos, a live video is playing, for example. And when we're comparing to a tablet device, there's more user reach. So, you know, I can pretty much guarantee that everybody here is going to have at least one phone on their person, but probably not many have a tablet. And I have a tablet at home. I didn't actually bring it today. I like using it, but I know I'm among the minority. I like using it for mostly media consumption, but it's not something I carry around in my pocket. It would just be annoying, and my pockets barely fit a phone, let alone a tablet. So people are more likely to have a device that will fit in their pockets, which could be a foldable, something that they can fold smaller and fit in a pocket or in a handbag. So there's that more flexibility and portability. You've got both the features of a phone, but also larger screen real estate like a tablet. So we've got these new devices. This is the Pixel Fold here. Unfortunately, not yet available in Australia, which I don't know what they're doing. I have thought about buying one. I haven't made the jump yet. I've got just a regular Pixel phone. I'm kind of waiting for version 2. It's always slightly better with new hardware to get the second version of something. But it is making a lot of noise overseas. But what's making more noise are these Samsung devices. So they're a lot more in the market. We can actually go and buy one here. So these ones, same as Pixel Fold, they open out. And then there are the Motorola devices. They have a clamshell version. I think Samsung also has one of these. So this is where we've got a very small screen on the outside, but they're now phone-sized screen on the inside. It's still a foldable device. So if you think about, if you're working on an app or thinking about a project, should you go ahead and update or build an app for a foldable? So these benefits of updating for foldables can give you a better user experience. So your user using the phone, if they do have a foldable device and they unfold and they get a great experience, they're going to be happy. These devices will become more and more common. I'm surprised they're actually not as common as we would think. I think probably because a certain fruit manufacturer hasn't come out with a foldable phone. A lot of the Android manufacturers are not spending their money developing foldable phones, but they will become more common, especially as they get more and more form factors. One of the things I am waiting for is potentially one that folds out 3 times so I can have my phone, but then also have my 16:9 video. That's something I'm waiting for, but I think that's a little bit far away. And letterboxing is no fun. So I'll show a few examples in a moment, but when we have a phone app that's restricted to a portrait phone size, if we put that on a landscape device like a foldable phone or a tablet, we get letterboxing on the side. And that's just no fun. You've spent all this money on a device with all this lovely screen pixels, and you're only seeing part of it. They've also, Google have now released promotion in the Play Store and improved Play Store SEO for foldable optimized apps. I'll talk a bit more about this later, but if you want your app to be able to be featured by Google, you usually need to have a really good foldable and tablet experience. And just a note on this, I've got a Wear OS app, and my app recently got rejected because I was only satisfying one particular screen size. So it's something that they are looking at, is how your app behaves on different screen sizes. There are also form factor specific ratings and reviews. So my app might be 5-star on the phone, but on a tablet, it might only get 1 star, on a foldable 2 stars. So it can be really irritating if somebody's searching for your app and they just can't find it, or the reviews look really bad on a specific form factor. So you want to make sure you're 5-star across the board. So our device capability is not equal to the screen size and shape. So if you've been developing Android for many, many years, like I have, we used to have some past assumptions. Back in the day when tablets didn't have SIM cards, and we could make a judgment call on what type of experience the user might experience on each device. So we used to think, oh, if the device doesn't have a SIM card, oh, it must be a tablet. We'll give them the tablet experience. Or if the device has a large screen, must be a tablet, must have no phone capability. Lots of assumptions were made. But these days, any screen size or shape can be a phone. It still can be internet connected. It can do all the things a phone does. So we need to make sure we don't make these assumptions. So we used to put in code stuff like this. If the network capabilities, it has cellular, we'll show the phone layout. And then if not, we'll show the tablet. I am really sad to admit I did have code back in about 8 years ago that did something like this. I regret this right now. So we definitely don't want that. And we no longer have only rectangular screens. Most of the apps these days are developed for a rectangular screen, either in portrait or landscape. But if we have a look now on the Pixel Fold here, it's almost a square. It's so almost it actually really irritates me. I wish they'd just gone full square. And the Motorola device, we can see that when it's unfolded, it's a rectangle, but when it's folded, it's kind of like this sort of more square, tiny screen on the front. So we can't make the assumption that everything can take a list or can take a rectangular display. We also have multiple active cameras. With this Motorola device, we've got cameras in the when it's unfolded and when it's folded. And we can use either of them at any time. We could also show the image of what the user's looking like through the camera on either screen. We've also got multi-window support. So this is relatively new, and I think a lot of people don't know this actually exists, but you can run apps side by side on a lot of devices, especially the new ones. And the apps must be able to work even when they're side by side. We can have them laid like in a grid, like on the top one there, or on the bottom one where they're overlapping each other. And we want to make sure that no matter which one the user's looking at, it's showing up-to-date information, they can interact with it, and it's not going to break or die. There's also new drag and drop capability. By being able to show more apps on the screen, we can drag content from one to the other if it's enabled by your app. So the key for this is having adaptive functionality and adaptive layout. We want to make sure we're looking at what the device has or what the allowed space is for the app, and then we adapt to that. And so we can adapt the layout and the functionality for what we're given, rather than making those assumptions. So large screen development and foldable development, it's not just the visual user interface, but we've got all these other items as well. It's not really what I'm going to focus on today, otherwise we would be here for about 3 hours. I'm going to mainly focus on the visuals, but these are things to also consider as well when you're developing for foldables. So there is now a large screen compatibility checklist, and this is what Google use when they're evaluating where your app should sit in the SEO of the Play Store and whether it's accepted or rejected. So there's the tier 3. This is basic, it's large screen ready. So this is an example of letterboxing. So tier 3 would mean that you're not letterboxed, that you've actually expanded to fill the view. If you're letterboxed, you're definitely not going to do well in the Play Store SEO. Tier 2 is better. So it's large screen optimized. And this might be familiar if you've done any responsive web development or if you've done Android development for a long time. What we would have is we have a phone version and we have a tablet version. They look great. We've got two, one and the other. There's nothing in between. And we've at least made an effort to design for the large screen. For tier 1, the best layout is where we're large screen differentiated. So there's specific experiences that have been developed for foldables and for large screens. So in this case here, we can see it's a foldable device. We've got the video playing on one half and the video controls on the other half. So they've actually made an effort to make sure that there's a specific experience for a user who's using the device this way. So if you're going to go into development here, you can check out the requirements here, and they take you through which things you need to have for each of these. So if you're going to go ahead and design for foldables, if you're like me, you have very little design skill. Don't ask me to pick colors or draw pictures or anything. It's definitely not what I'm into. There are a whole bunch of inspiration elements that you can take from the Google Docs. So if you're getting into app development and you're like, I don't know what my app should look like, you can just go ahead and take a look at all of these and just copy one. They're there for it. They have all the dimensions there for you. You're all good. They also have a lot of example canonical layouts for you. So if you are getting started, you can take these examples and build your app around them rather than starting from scratch. And so these ones are giving you ideas, and they're all categorized into like media apps should do this, or chat apps should do this. So you've got examples of how they should be differentiated. What we also want to consider is maintaining the state and the continuity. So if we have a look at this GIF here, we've got a chat app. As we unfold the device, we're still maintaining the same position. We can still see the chat that the user is interacting with. So this is just the same as handling on configuration changed if you have been doing some Android development. We want to make sure that when we rotate a device, we keep the state of where the user is. We don't want the app crashing. We don't want the user going back to the start of the app. We don't want the app restarting. We want to make sure that state is maintained. So we need to take into account rotations, like we always have, but also the folding and unfolding. We need to handle those app start, stop, and resume states, and retain all the things that we want to, like the text type, scroll position, that sort of thing. And a key thing is that we need to maintain that continuity even when the app is not in the foreground. So the key thing with these multi-window modes that I showed earlier is that even though we're seeing multiple apps on the same screen, only the one that the user is actually interacting with is in the foreground, which means if the app stops or breaks or does something weird when it's in the background, if I'm looking at one of them and the other ones all suddenly die, then that's a problem. So we need to make sure that even when the app is in the background, it's still behaving as the user might expect, because they still might actually be looking at it. The key is the layout continuity and predictability. You don't want your user being surprised in a bad way about how the app is behaving when they open or close their device. You want them kind of surprised in a good way. So we look at a bit of code. So these code examples are based on the Code Lab, Jetpack Compose Code Lab for adaptive apps. It's very easy to get started. So if you are looking to get started with Android development, this can be a good one. There's lots of other ones available that are more basic, but this one can be a good one to get started. So I've just taken a lot of the code from here. The first thing you might need to think is, do I need to buy a foldable device? I mean, we can't here even. So I have to go to America and spend $3,000, $4,000 on getting one? No, you don't need to. You can use the resizable emulator. So there's an emulator within Android Studio, and you can select between the phone version, unfolded phone, and tablet. So we can see how our app behaves in all these different experiences just by changing the emulator. We don't actually need to buy one. You can also set different screen size and states to check what it looks like in that small square version, the large square version, different rectangular views. It's all configurable. We can also look at the hinge orientation and state. I mean, this emulator, I did take this video a few months ago. It looks a little bit strange. The hinge is very small there, but the key factor is that we can still get the data. I was hoping this was going to be updated or fixed. I don't think it actually has, so I don't know. But we can play with the hinge and play with the accelerometer and see where our device is positioned so that we can test this and we can see how our app behaves. So how do we go about detecting the screen size and the state? We use window size classes. And this might be familiar to you if you have done some web development, or you've used the view-based layouts in the past where you might have had different folders for different layout sizes. But essentially, we've got different sizes here: compact, medium, expanded. We can do this in both height and width if we want to. But these are opinionated. Google has set out a few standard ones, but if your app should behave differently, you can make your own up. You can create your own that have different breakpoints based on what your design requires. Generally, we care about width more. Most apps have some sort of scrolling list in them. It's just a general thing. So we generally only care about how that width is behaving. We don't really care about the height because the user can scroll. But for some apps, you might care about the height only, or you might care about the height and width, and it completely depends on what your app is going to do. And as I've said before, we don't want to use this as is tablet style logic. I don't want to go, is it expanded? Okay, it's a tablet. Not used for that. And this is because when we've got two apps in split screen, they can report different sizes. So for example, here, we're categorizing the display area available. And the window size class can change throughout the lifetime of the app, so as the user resizes those. So if we look here, the actual device might be medium expanded, height, width, and it might be, but this one in orange there might be medium, medium. The map on the bottom is compact, compact. So even the device is a tablet. All these apps inside are not going to behave as if they were full screen on a tablet app. I'll probably take questions at the end. Just remember it. So we can use this both in the old view-based system and also in Jetpack Compose. So with the view-based system, we can use the Jetpack Window Manager library. It's more complicated to implement, and you need to set those breakpoints really explicitly. I probably would go back to the old folder-based layout situation if I was going to do that, but you wouldn't get a lot of the features that you do with Jetpack Compose. And for those who are new to Android, Jetpack Compose is the new fancy UI building kit that we're all using, and it's just the latest buzzword, so get on it if you're starting. So with Jetpack Compose, we can use material window size class, and we just use a really simple method called calculate window size class. And that's what I'm going to show you today. So as usual, we have dependencies, just use the Compose bill of materials, and then the window size class dependency. And in our main activity, we want to do this at the very top level of our app so that we get all this information in one place and we can pass it down to our individual composables. If we try and put this logic in multiple places in our app, it gets very confusing and we might get some really weird behaviors and find a lot of bugs. So you want to calculate this sort of information at the very top level. So in our onCreate, we're going to set our content like we usually would with Jetpack Compose. We're going to calculate our window size. I've got a UI state there, and in my app, reply app, in this case, it's a chat app. I'm going to pass in my UI state and pass in the width size class. So the calculate window size class is a compose remembered state, which means this every time the state changes, it will update the value, pass it into reply app, and reply app will recompose and will relay out. So it will respond to the change. I don't have to do anything. The operating system will take care of it for me. For this app, I only really care about the width, so I'm only going to pass in the width size class. I don't need to worry about the height at all. And because I'm only passing the width in, Jetpack Compose is smart enough that if the height changes, it won't need to worry about it at all. At the time of writing this, which was a couple of months ago, this was experimental, so I just needed to add the opt-in experimental notification. Don't know if it still is. Possibly is. Everything seems to be experimental these days. So if we want to go ahead and respond to that screen state, what can we do? So if I'm going for a very naive, that tier 2 implementation where I just want one layout for phone, one layout for when it's unfoldable, I can just take a look at that window size class and do different layouts. Very basic. I've got my compact layout, my medium layout, my expanded layout. Great. I've achieved tier 2. But we want something a bit more like this, which is going to be a little bit smarter and provide different interactions. So we need to respond to the screen state dynamically. So we have a concept called postures. And this is our fold states and how our app behaves. So we have the normal posture. So this is when the app is, when the device is just folded or unfolded, nothing in between. It's pretty straightforward. But then we also have tabletop and book posture. This is when the device is either folded and sitting horizontally or vertically. As you can think, like a tabletop, like a book. That's when the device is half opened. We also have something we need to consider, and that's the separating type devices. There are only a few of these. Can't even remember one at the moment. I think it might be a Lenovo device that has actually a hinge down the middle. So it means that you don't really want to have content that's breaking across both screens because it'd be really weird to just start reading some text and somehow have to cross over a hinge and read on the other side, or playing a game on both screens would be very confusing. especially if you're trying to shoot something like that. So these devices have a separating aspect and an occlusion on them. You can also sometimes consider things like camera position as an occlusion, but in this case, we're just talking about the hinge. So what I want to get is my device posture and then respond to that. Got my normal posture. I've got my book and tabletop posture. And these ones, I'm passing in the hinge position. It's really important to know where the hinge is. And then I've got my separation. And that's got the hinge position. It's also got the orientation, so I know which way up it is. So I can observe this posture using a flow. I've got my device posture flow. I'm using window info tracker, so it will track this change. I've got my window layout mode. I'm passing in the activity. This is a life cycle flow, so it's going to respond as the device is in resuming or pausing, for example. And then I've got that layout info, and I'm going to get the folding feature from that. So the folding feature are those display features that I was just talking about. So I've got these folding features. It does, which is really interesting, it does give you a display feature list. At the moment, the only one that's there is folding feature, but I have the feeling that Google are going to add some more things in here soon. So I'm going to grab that folding feature. And this is only going to give me the features that are present within the current window. So it means that, for example, here in that purple one there, it's not going to give me the hinge information because the purple doesn't overlap the hinge, whereas the pink one does overlap the hinge. So it's going to give me that information about that occlusion in the middle. So it means it's only going to look at where that app is currently positioned in the operating system. So if I move that app from each side, it'll change. And as it goes across that hinge, it'll give me that information. I can adjust as needed. When it goes fully on the other side, again, it will give me that information and I can adjust again. So now I just need a switch statement and I can take a look at all these postures. So I can decide which one my app is currently in. So we can see for book posture and tabletop posture, super easy. We're just looking to see if it's half opened and then what the orientation is. Separating is a little more tricky. We're, again, looking to see if it's flat, but we're also looking to see if it's separating. But what we also need to pass in is the hinge position. So that's the bounds of the folding feature. I am kind of wondering at the moment, as I said, they've only got one, but if maybe one day there might be like two-dimensional folds, I'm kind of hoping that would be kind of cool. But at the moment, it's just one rectangle on the screen. So on a device that has a contiguous screen, like the Pixel Fold or one of the Samsung devices, it's just like a 1 pixel sized line, essentially. But on something like this that has an actual hinge, it's actually a box. And this can give me the information of not to put any content that the user cares about in that box. And I also need to know about which side to put my content on. So why do we care about this? If it's creased, maybe it's okay if some of the content goes across, but not if there's a gap in there. So if it's not separated, so it's still got a crease there, but it's not flat, we still don't want our content to break across the screen. It would be a little bit weird if I was looking at a book and the text went the full width of the book. I'd like to have it 2 columns potentially. If it's not separated but flat, that's okay. We can go full width. But if it is the separated, we never want any content to break across that hinge. And so that hinge position is important. So we can put that different content on either side. So in these examples, we've got some comments and interactions and emojis for a group video call, the controls for the video, as I said before, and the other one we've got a keyboard. So if I know where these positions are, I can make sure that certain content is on the flat side versus on the non-flat side. And that's where we're starting to get into the tier 3 designed specifically for a foldable device. So putting all of this together, we've got our device posture flow. I've just hidden all the text for the moment. And then I can pass this directly into my app. So it's responding to the window width, size, and the posture. And I can produce different layouts based on this. And this is how we get to this sort of layout. So some of the benefits of this. We're confining the screen size and logic to a single location. As I said before, we don't have to copy and paste this code in multiple places. It's easy to keep everything in sync. And we can pass the state down into our composables. This makes everything a lot more simple and makes the previews easier. And just pass down the configuration. And the individual composables don't need to care about what's happening in the app overall. And this means we don't need to make a whole new layout for every single configuration, which takes forever. And this enhances our reusability, which as developers is so important. So when we think about navigation, we want to make sure we're navigating for these responsive UIs. So if we have a look at the screenshots on the left there, or the right, sorry, for a tablet, we might want the navigation in a different position, whereas on a phone, we might want it at the bottom because it's easier to reach with the thumb. So we want to think about those ergonomics. How is the user going to go and tap each of these sections? We want to use a single navigation graph. So we want to make sure that we're not producing multiple navigation graphs because any of these things can change at any time. We can use remember savable to retain the state across configuration changes. Some details about that if anybody's interested. I can share these slides later. And if we're transitioning between states, so we have a look at this GIF here, and I did get this off the Google Developer Docs. We can see this nice little animation as it's coming in. There's currently no way of telling the amount of how it's unfolded and folded. It's either just flat or it's half opened. To make this animation, we can probably use something like target-based animations, which allows to go from one position to another smoothly. I'm going to add a little star here. I was talking to a Googler recently, and he's like, yeah, of course you can tell how much the animation is going or how much it's folded and unfolded. I'm yet to actually find this, and I'm actually going to spend some time researching this and take it up with him because I think he's lying. But anyway, we'll get to that. His name's Oscar. But yeah,
it's real. It's just internal.
Yeah. Well, he was one who wrote the docs, and he's like, no, we can.
So it's the undocumented thing.
Yeah. Have you seen it?
I have a friend that spent 8 hours trying to find a feature that was in the Google Docs, but it was only internal because the Google Docs are auto-generated off their internal tools.
That's what I think, and I was talking to him about it, and I'm like, I swear it's not in there. I've written a talk on this. I've looked through this in detail. He's like, no, it's there. I wrote it. I'm like,
yeah.
So anyway, I need to do a bit more research, and then I'm going to go back to him and get him to fix it. So
It's still experimental.
It probably is. That will be the answer for everything. So possibly there is. We'll see. Maybe I'll write another talk based on this. So something else that also was just released, and literally I think on Thursday. So I haven't actually looked at it myself yet, but I just included it in this talk. Is they have released some new adaptive layouts that you can use straight out of the box. So list detail pane scaffold, which gives you that list and the content on either side, and this will respond to the device size. And this means you can, have the right size and spacing will be handled for you. And there's also navigation suite scaffold, which puts your navigation on the side for a tablet and the bottom for a phone. So these are a bit more opinionated from Google. You don't have to use these, but if you are getting started, it could be something that's good to try. As I said, I have not had enough time to try these out yet, but we'll see. There's lots of data and architecture considerations for you. I'm not going to spend a lot of time on this. We do think that it's tempting to only load the data that we want to show on the screen, but we've got to remember that as we fold and unfold the device, we might need to show more data. So we need to load all of the data the user might need, no matter what the posture is. So the screen size and shape can change at any time. So for those nice transitions, we have to load all the data. So this might seem a bit weird and performance might suffer, but if you do it the right way, it should be okay. To do this, we can hoist the data to the highest possible point to make it available everywhere. And this also helps with us preserving the user state. And this means that our changes are only isolated to the UI. So if we're presenting all the data to the UI, it can pick and choose which pieces it needs. Display modes. This is also something that's relatively new. I only found it when I was revisiting this talk and making sure it was all up to date still. We can also interact with the different displays on these foldable devices. So we can move the activity to the outer screen. This might be useful if you're taking selfie and you want to have your camera preview on the outside of the screen rather than the inside. You can also have dual screen mode where you could have that content on both sides, which could be interesting maybe for a game or some immersive reality, that sort of thing. So as I said, this is quite new as well, just touching on this briefly, but these things are available as well. especially with the dual screen mode, which is the top right there. A lot of this is provided by the operating system, so they will make all the interactions for you. You just have to say that you want to use it. Testing, something that we always have to do, but we don't like doing. Yep. Yeah, never got time for testing. So we can use, we can do it off the phone. We are able to use emulators. We can also use things like snapshot testing and UI testing. We can use Espresso Device API, and this will allow us to test specifically our foldable or large screen devices. We can execute it synchronously and improve it in reliability. And you can specify the exact folding feature and the window layout info for that test. So it means we can try different configurations. And this is very new. When I did write this, which was a few months ago, you had to have specific Android Studio requirements. I think it still is very new. I've seen it's mostly experimental. I have not played around with it yet. I usually just use a regular phone or an emulator myself.
$3,000 on a...
No, I have not. Yeah, no, I use the emulator mostly. If you are keen on taking a look at some of these things, here's a bunch of links. But again, come talk to me later if you'd like to see some of these. And that's pretty much it. Any questions?
I had a question.
Yep.
When we're talking about like the screen sizes, you went from like compact, medium and stuff. Would it not be more reasonable to use perhaps aspect ratio or like to maybe even abstract it out so that, you know, later on there's a device that's like as big as a newspaper, I don't know, or something like that, where that might be more useful than specifying specific sizes and really narrowing it down to like 480 or 640.
Yeah, well, you can do that definitely.
Okay.
If your app cares about height and width, then maybe that's what you can do. But why you might not look at the aspect ratio is because if I have a very simple app and it's blown up and it's blown up to a big size, there's going to be a lot of wasted space, or the text is going to be huge, or the text will be smaller within a large space, if that makes sense. So that might not apply for all apps. It just depends what you're trying to do. Most things I've experienced would use looking at those width in those like different categories. But again, different apps. And something like a game, you might want to look at the aspect ratio and just blow everything up to be larger. But that won't work in all cases. And your app layouts would need to be really responsive on the height and width in terms of percentages or aspect ratios. So you might have text that grows with the screen size or shrinks. Most apps don't really use that. And I have found it not so great when implementing that. I'm trying to do that for an app at the moment. So it can add a layer of complexity. Just depends what you're trying to do.
Right.
Other questions? Yeah.
I think I might be misunderstanding something.
Okay.
When you say you go from level 2 to level 1, it's first level 2 is taking into consideration that compact, normal, expanded. And then when you drop down to level 1, it's considering the postures.
Yeah. So level 1 is, I think, is the best. Is okay. what they're saying. Yeah.
So then, how can you avoid it? It feels like it's this massive tree that by the bottom you've got like, compact book posture, standard book posture.
Again, it depends on I think this is the slide here.
The permutations.
Yeah. I feel like you're making 72 different UIs.
There we are here. And it completely depends on how much time you have and the type of app. So, I mean, I'm working on one right now that's like simple little grid of things and click on them and they do things. I probably don't need to go down to tier 1. And I'm also doing this in my own time, so I don't care. But if I'm doing this for a production app that I might be doing for a client that I'm working 8 hours a day in, I might actually care about this and spend more time doing it. And you wouldn't necessarily have 72 different combinations. With Jetpack Compose and also with the view-based system as well, you only have to, all your smaller items are building blocks. So those smaller items smaller composables, will be the same across multiple different layouts. You just including them. You might just, on a tablet, have 5 of them, 5x5 grid, as opposed to a 3x3 grid. So you're not creating whole new layouts. You just might be making small tweaks. So, which might be things like more columns or larger images, for example, larger text size. So you don't have to create full layouts for each one.
You'll still have that that switch statement, but it will only be for one parent composable.
Yes.
And most of it will stay the same.
Yeah, and you might not even have that switch statement everywhere. You might just pass that value in, and only something where you care about it will you have that switch statement.
Maybe you don't even care about the foldable state.
Exactly. Yeah. So you might have this switch statement will have only 2 states because that's all that you care about for that particular part. But for that overall layout, you might have 2 separate ones. But the way Jetpack Compose works, I don't know if you've used it before. Yeah, you can reuse things a lot.
Yeah.
I can show you some examples later if you want to see. Yeah.
I have one small tiny question. What happens if you don't do this? What's the default?
So if you've restricted your app to portrait, and if you're not targeting a specific SDK, I think you get letterboxed. Which
Foldables just black.
yeah,
Oh.
yeah, it's really sad.
That's changing now though with the
Yeah.
Android 14 feature drop that came out earlier this week.
Yeah,
Users can actually stretch it out over the entire screen.
but if you stretch it out, your app may look terrible.
It's like running Instagram on an iPad. It looks terrible.
Yeah,
Oh,
yeah, it's a great
It's
example.
just tiny column and just
Yeah.
white space.
Yeah, it's actually black space, which I think is slightly better. I did have an example of it here somewhere.
The resolution might be trash.
Yeah, it's like this.
It's
It looked
not
like this.
scaled up. It's not, it's literally stretched and scaled up. It's not optimized.
It's like running an if you use an iPad, iPhone. It's like when you get an iPhone. iPhone app for an iPad.
It looks like a kid's device.
It
You're like,
does.
oh, big buttons. So yeah, so there's those 2 defaults. If you're targeting a newer SDK, it will probably stretch it out to the full width, but again, it'll look bad. So that's the default. That's what you get. So if you can get it to that full width and it looks okay, then you probably qualify for tier 3, and that might be okay if it's just a hobby app that's not meant to do many fancy things. It's no problem. But yeah, if you want to look at it a little bit better, you kind of want these sorts of things. Do we have time for any more questions?
Yeah.
Any other questions?